Global Gridlock Report: IntelSat satellite crashes in space, raising concerns about orbital debris in a surprising and alarming development. The IntelSat 33E satellite has disintegrated in orbit, intensifying global fears about the growing threat of space debris. IntelSat, a major player in satellite communications, confirmed that the Boeing-built satellite, launched in 2016, fell apart earlier this month. This unexpected failure highlights the persistent risks involved in maintaining aging technology in space and the challenges posed by orbital congestion. Before we proceed, please like, comment and subscribe to help us with the YouTube algorithm. According to IntelSat officials, the satellite experienced a propulsion anomaly that compromised its operational stability. Engineers had been monitoring the situation for months, hoping to correct the issue, but the failure proved catastrophic, leading to the fragmentation of the satellite. The exact cause of the malfunction remains under investigation, though Boeing and IntelSat are collaborating to determine the root of the problem. The disintegration of IntelSat 33E has created numerous fragments now floating in geostationary orbit, an area already saturated with satellites. Space agencies worldwide are concerned that even small pieces of debris, traveling at high speeds, could damage or destroy other satellites and spacecraft. A collision with critical communication or GPS satellites could cause severe disruptions to global networks, air travel systems, and military operations. Orbital debris, often called space junk, is becoming a growing crisis. The incident involving IntelSat 33E adds to the more than 30,000 pieces of tracked debris already in orbit. The risk of creating a chain reaction, known as the Kessler syndrome, looms larger with each satellite failure. In such a scenario, one collision could trigger a cascade of further collisions, rendering key orbits unusable for generations. Satellite operators, including IntelSat, are facing increasing pressure to ensure their hardware is equipped with end-of-life protocols, such as deorbiting or relocating defunct satellites to graveyard orbits. The IntelSat 33E incident underscores the urgent need for more robust industry regulations and stricter satellite maintenance standards to prevent such mishaps in the future. In recent years, several initiatives have been proposed to address the space junk problem. Some companies and space agencies are exploring innovative solutions, including using robotic arms or nets to capture and remove defunct satellites. Others are testing drag sails and tethers to accelerate satellite re-entry and reduce orbital clutter. However, these technologies remain experimental, and the latest incident highlights how far the industry still needs to go. International bodies like the United Nations Office for Outer Space Affairs, UNOSA, have called for greater cooperation between countries and private entities to mitigate the risks posed by space debris. However, achieving consensus on binding regulations has proven difficult, given the competitive nature of the space industry and differing national interests. The IntelSat 33E's disintegration adds urgency to these discussions. As more satellites are launched by governments, companies, and even space tourism ventures, the risks of accidents and congestion increase exponentially. Without immediate action, the growing debris field could hinder future exploration and disrupt vital communications infrastructure. IntelSat is also facing financial fallout from the incident, with industry experts speculating that insurance claims and reputational damage could be substantial. For Boeing, which manufactured the satellite, the failure raises new questions about the reliability of its space technology, particularly as the company competes with newer players like SpaceX and Blue Origin. As the space industry rapidly evolves, the IntelSat 33E incident serves as a stark reminder that technological advancement must be accompanied by responsibility. Space, once considered a limitless frontier, is becoming increasingly crowded. Failure to address the risks could jeopardize not only future missions, but also humanity's reliance on satellite technology for communication, navigation, and observation. Global gridlock will continue to monitor developments as the investigation unfolds and industry stakeholders grapple with the complex task of balancing progress with sustainability in space. The IntelSat 33E failure may serve as a turning point, forcing the global space community to take concrete steps towards safer and cleaner orbits.